Martin, I've got bad news for you. Today we're talking about feelings. What do the pros feel? And that's how you'll understand your motorbike better as well. That's the topic of today's video. You've just had a mini heart attack there, Martin, talking about feelings in front of thousands of viewers.
Is very tricky.
Yeah, but now it's about feelings for the motorbike. And that's the bit where you like chatting with me again. Today we're talking about feelings for the motorbike. Is it true what people say about motorbike experts? That they can feel better what a bike is doing? And now we're going to try to bring that across in the video, the know-how, so that after they've watched it, people will understand the motorbike and know what my treasures on two wheels are actually telling me. Martin, where do we need to start? We're talking about what the pros feel. When we were preparing, you went straight in with the frequency spectrum. I almost keeled over. But we can't get around it. Vibrations are based on frequencies. How can we get started?
The main reason why riders often come to us to have certain phenomena explained, things they're noticing on the bike, is first and foremost vibrations. That's what you perceive most clearly on a motorbike, apart from the riding dynamics. Of course, there are also engine noises, but the next step is mainly about being able to detect any disturbing vibrations and then finding their causes. From a technical point of view, there's actually a fairly simple way of assigning these two frequencies if you just think it through. Basically, vibrations can only ever be caused by moving parts. And the number of moving parts on a motorbike is relatively limited. We've got the front wheel and the rear wheel, which rotate. By moving, I mean rotating parts. Then we've got the engine and the chain. Those are the only components on a motorbike that can cause vibrations if we leave chassis oscillations to one side. Here, we are primarily talking about real vibrations that you can actually feel.
That's already an incredibly important point. So that means the symptoms you're seeing can sometimes be a long way away from the actual cause. And you probably notice it, or rather feel it, at the handlebars. But that doesn't mean you have to start trying to fix things at the handlebars. Instead, you need to feel at the bars what kind of problem it could be. What are the typical issues you feel at the handlebars?
What you feel at the handlebars can be either high frequency or low frequency oscillations or vibrations. And from that frequency spectrum, you can already work out fairly easily what the cause might be. As we mentioned at the beginning, it can only really come either from the engine or from the rotating assemblies, for example, with the chain drive. And those differ quite dramatically in their frequency spectrum. You don't have to be a specialist for this. I still have to explain it a bit in terms of frequency. Otherwise, it's hard to describe what's high frequency and what's low frequency. Basically, everything that can be generated by the tires, the wheels, the rolling assemblies, and the chain, because of the speed range we're dealing with, between 50 kilometers per hour and 150, 160 kilometers per hour, ends up somewhere between 5 and 20 hertz. Somewhere in between. That's a unit that describes how often this oscillation or this amplitude occurs within 1 second. So you can imagine if we say 5 hertz, that's 5 times per second. You can picture that, it's roughly in that range. And those are frequencies that in principle can only be generated by the rolling assemblies and by the chain. All frequencies that are higher, which you perceive, for example, as a tingling at the handlebars, are extremely high frequency. They are many times higher than what we've just been talking about. Those are frequencies that can only be generated by high revving systems such as the engine. All rotating parts in the engine, the crankshaft, gearbox shafts and so on, can cause that kind of disturbance. It can be an imbalance in the crankshaft, which is also why fine balancing is often carried out on crankshafts, because it significantly improves smooth running and reduces that tingling at the handlebars. That's also one of the reasons why most engines have balance shafts built in, because an internal combustion engine, due to its oscillating motion, always generates vibrations, even if everything is balanced. You have to rotate counterweights against those vibrations. These vibrations are more or less compensated for. You can't eliminate them completely, There are a few exceptions, for example, with a 6-cylinder engine.
Martin, now we need to keep things realistic. One thing does have to be said. In principle, I know you'd love to start fine balancing crankshafts, but for the average end customer out there, at the end of the day, you have to accept that certain motorcycle models have a higher level of engine vibration. And then you can basically only treat the symptoms in practice, like you can fit bar end weights, you can add more rubber to the footrests, that kind of thing. You have to say it as it is. Whereas with low frequency problems, as an end customer, you don't have to be satisfied and say, look, there's nothing I can do, I'll just add a bit more rubber. There you really can, sometimes with a small financial investment and little effort, fix small issues with a big effect, right?
Basically, that's true. You can also listen a bit to what's going on inside the engine. There are cases, for example, where timing chains, which are usually tensioned by an automatic tensioner, can become faulty. On various bikes, that's a bit of a weak point. And when the chain becomes too loose and starts to oscillate, it also generates vibrations. I'm not talking here about the vibrations an engine naturally always has by design. What I mean are vibrations that occur in the engine that are out of the ordinary and are caused by a poor condition of the engine. That's where you can actually do something about it. But generally speaking, that's the smaller part of the issue. The bigger part tends to come from these low frequency vibrations, because that's where the causes are usually found first and foremost in the rolling assemblies. And those can arise very simply, for example, from the tire itself not running true, a vertical hop, if you like.
So basically that means it's a manufacturing defect or a quality issue with the tire?
Exactly, that's right. Which then leads to a hopping motion. You can see it very clearly when you put it on a test bench. When the rear tire is spinning, the rear of the bike starts to bounce slightly, and that shows up exactly as those vibrations. Or a rim defect, especially with spoked wheels when you're riding off-road on enduros. If you take a proper hit on a rock or on an edge, it can very well be that the rim deforms slightly and then you get an out-of-round run. Or ultimately and very simply, an unbalanced system, meaning poor wheel balancing of the tire. And there's a very interesting effect there. You mainly feel these imbalances at the handlebars, of course, because that's one of the main contact points between your body and the bike, even though the cause is often actually at the rear tire. As a rule, or from experience, I know that it's mostly the rear tire that contributes to these kinds of issues. We've had a lot of customers come in and say, yeah, I've got these vibrations, I've already been to the dealer, I feel it at the handlebars up front. They looked at the front tire but didn't find anything. And that's often because the problem isn't at the front tire at all, but at the rear. And then there's an additional effect like the chain drive. There is also shaft drive, of course, but that's the smaller proportion of bikes we see. First and foremost, it's the chain, and that can go as far as unevenly elongated chains, meaning overstretched chains. That can happen if the chain is over-tightened and then the suspension compresses hard once, where it overstretches, so to speak, but only at a specific point. Then the chain develops what's known as a vertical runout. When you start turning the wheel, the chain becomes longer at certain points and shorter at others, and that creates an oscillation in the chain. You can even see this sometimes on the power readouts. When you do a dyno run on our test bench, you see these little spikes in the curve. And that's always caused by an unevenly stretched chain. And that oscillation is something you then naturally feel at the front as well, at the handlebars.
Wait, let me just explain that briefly, Martin, because I didn't know this myself. An unevenly stretched chain means that the individual chain links, the chain elements, are stretched to different lengths around the entire circumference. You have to say they're damaged. That means if you've caused that damage, and most of the time it's the user who's caused it by tensioning the chain too tightly, then when you ride over a bump and the suspension compresses, the chain is overstretched in certain sections, and then you have to fit a new chain because of excessive tension. And you can really feel that on the test bench where the chain is literally moving up and down.
Exactly, because the engine is always pulling with roughly the same force, and depending on which section is under load, sometimes the more stretched section, sometimes the shorter one, the drive force is reduced slightly, then increased again. And that not only creates a vertical run out in the chain when you spin it on a stand, but also fluctuating tensile forces in the drivetrain. And that's what generates these vibrations. You can recognize these vibrations best by whether they change with road speed, because if the vibrations come from the rolling assemblies, then their frequency has to change with speed as well. That means the slower I go, the lower the frequency of the vibration becomes. The faster I go, obviously, it's exactly the opposite. And that's a very good way of identifying that these out of round effects or vibrations are coming from the rolling assemblies. If you put a brake disc under very heavy load, the material structure can partially change, especially on the racetrack. And then you can get situations where the brake disc, what we call it in technical terms, becomes glazed. And that doesn't usually happen evenly around the circumference, but more in certain segments and less in others. Once that's happened and you start applying the brake and pressing the pads against the disc, sections of the disc pass through that generate more friction and others less because of this surface change. And that naturally creates a corresponding juddering at the brake, and that also changes with speed in terms of frequency. So if I brake from high speed, I get high frequencies, but as the speed drops, the frequency decreases more and more until it eventually disappears. And these are all indicators like that, this change in frequency, which is the reason why we have to bring frequency into it a bit, to be able to identify where the cause of these vibrations lies. When it comes to the engine, to come back to that, again, this of course also changes, but with engine speed, that means if these frequencies are caused by the engine, I can verify them fairly easily. Even when stationary, I don't need to ride at all. I just need to rev the engine up through different RPM ranges while standing still, and I'll feel those vibrations as well. That's also a very good way of telling if you're not sure whether it's coming from the wheels or from the engine, okay?
Now, I think we've talked a lot about imbalance and vibrations and so on. Is there also something where, as an experienced expert, you can really feel something when we're talking about the engine? Do you always need the dyno, or are there a few things where you just go over, put your magic hand on it, and you already know no need for the dyno? It's running too lean, too rich, or something else isn't right?
There are definitely a few things you can already check to some extent when stationary, when it comes to how the engine runs, when it comes to bearing damage and things like that. I can actually detect that very well at a standstill, sometimes even better. You don't need high revs for that at all. With bearing damage, the bearing clearance simply becomes larger than it should be, and that leads to a kind of rattling and clattering noise in the engine. You can often recognize that better at low revs, basically idle speed, than when riding. You can hear that quite well when stationary. And as we mentioned earlier, timing chain issues as well. Timing chain rattle is often easiest to pick up at low to mid revs. Anything beyond that, though, I really do need the dyno, because there I can apply load as well. I can't do that at idle, otherwise it would immediately hit the rev limiter. And I can also listen into the engine much better when I'm standing next to the bike, accelerating it under load, and I perceive a lot more that way. What you can also do on the dyno, in addition to vibrations, is check whether the engine is running too lean or too rich, especially in the part load range. For example, you can tell roughly from the load change behavior. If I fully close the throttle and then start to open it slightly again, I can recognize whether the engine is running too lean or too rich in broad terms. Nowadays, with ride-by-wire systems, that's become more difficult because the throttle behavior is controlled by the electronics, and that transition is smoothed out anyway. That means I already have a relatively easy way of achieving a very smooth load change, regardless of mixture preparation. Before that existed, this was a very important factor, because it was how you determined how aggressively the engine responded to the throttle. You can still work with that today, but in some cases, it's actually easier to deal with it via the ride-by-wire settings. In the past, it was like this. You could define extremely clearly via the mixture how aggressive that load change was going to be.
Sorry, but you'd basically do that on the dyno, right? You'd look at what's happening on the dyno before opening the throttle, then that first initial movement on the throttle grip, and then you feel, okay, that's too rich or that's too lean. And these days it's usually too lean with all this Euro 5, blah, 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 or Euro 4 already before that.
Exactly. That was purely down to feel. It wasn't about measured values at all. And it's also hard to measure because as soon as you close the throttle on the engine, you can hardly capture lambda values anymore because there's no longer any real gas flow. So the sensors and the measuring equipment basically stop working properly.
Now we need to explain that, Martin. How would a normal rider notice this? They roll off the throttle and then open it again. If the engine is running too lean, what does that feel like?
If the engine is running too lean, the load change is often very harsh. That means the power kicks in immediately as soon as you even slightly start to turn the throttle. If it's a bit richer, everything happens more smoothly and with a bit of delay. You really had that feeling, I don't know, those of us who still come from the dinosaur age, like the two of us.
Hey, the people who still ride two-strokes today, those bikes are still running on two-stroke.
That's true, but especially with race bikes, which are really pushed to the limit in that respect, this kind of setup was extremely important to achieve a proper load change. You could test that very well even when stationary, because after revving it up, you could always see how it picked up the throttle again. That was also the reason why race bikes were blipped so much while warming up. People might remember that from back in the day in the paddock, when they were constantly giving little throttle blips. The mechanics, while warming the bike up, could already tell from that whether the needle, which was mainly responsible for this part load range, was positioned correctly in the carburetor, because that gave you a nice smooth transition. So when we talk about having a good setup on a two-stroke engine, it's like this. When you roll off the throttle and then open it again, it gives you this kind of transition. That would be good. That's exactly what you want, because that's what you know from 4-strokes in the part load range, giving you a very smooth power delivery. If it's too lean, it snaps straight back onto the throttle. And that's precisely the situation you don't want. And with 2-strokes, that was always the case when the mixture was too lean in that area.
Wait a second, I need that for my son's bike. So I need to move the needle up 1 notch?
Yes, exactly. You can control that with the needle. And it's very similar on a 4-stroke as well, just not nearly as aggressive because there are much larger rotating masses inside and everything is smoothed out a lot more. But put simply, it's exactly the same principle. With the mixture, you can determine how smoothly the engine starts to burn, as we call it in technical terms. In the combustion chamber, when you roll off the throttle, there's no combustion happening at all. And the transition during the load change, if you like, between rolling off the throttle and opening it again, is the moment where the combustion chamber goes from no flame to suddenly having combustion again. The engine starts burning again, and you can use the mixture, richer or leaner, to determine how gently the engine starts burning again, and with that you can make the load change softer or harsher depending on how it's set.
Okay, well, Martin, I think we've pretty much reached the end. You have to say, the good news is, especially when it comes to wheels, you've got the situation that if you lose a balance weight or maybe the tire has slipped slightly on the rim at the rear, it really doesn't cost much money, but it has a massive effect on riding comfort. So don't just accept vibrations, react to them. What's important is that you really feel and listen to it properly. Because small cause, big effect, losing a balance weight doesn't cost much to fix, rebalancing it is cheap, but riding around with it is unbelievably annoying when it's running out of true. And yeah, hopefully we've managed to help you a bit there. One last thing I want to know, dear two-stroke friends, did Martin do a good job imitating a two-stroke, or was it pretty terrible? I'm not sure how I see it. I think it was quite okay, but maybe. Thanks, bye, cheers, and see you next time.